Hello maths fans, Dr Tom Crawford here at the University of Oxford, and today I'm doing a maths A-level exam. Now this is something quite a few of you have requested, so I'm not calling it a speed run because I haven't done an A-level exam in about 14 years, but I have the 2018 Edexcel Pure Maths paper from the A-level maths course. I haven't looked at it at all. I haven't looked at the syllabus. I haven't looked at the formula booklet. I do have my calculator. So I found an old Casio that I think I had when I actually did my A-levels. So I don't know if this is still allowed or not, but this is what I've got. And I'm going to have a go at the full exam. I think I've got 2 hours to do it. Hopefully I can do it faster. I'm going to do it all on my iPad so you can see exactly what I'm writing, and we'll see how it goes. Okay. Let's do this. I'm quite nervous, I'll be honest. I haven't done an exam in, about 8 or 9 years, so this is pretty terrifying, but let's see what we've got. Question 1, integral. Okay, so Q1, asking me to integrate 2/3 x cubed minus 6 root x, which I'll write as x to the half, plus 1 dx. So I'm just going to rules of integration, x to the 4th over 4, minus 6, new power, 3 over 2, divide by that, means multiplying by 2/3, plus x plus c. Simplify that, and we'll get x to the 4th over 6, minus 4, x to the 3 over 2, plus x plus c. Right, question 2. Show this is a quadratic is okay, show the quadratic is positive. Right, so I've got x squared minus 8x plus 17. I want to show that's positive for all real x. So it's definitely a U shape because of the positive x squared. It's going to look something like that, passing through 17. Now let's just double check by looking at the quadratic formula. So if we've got imaginary roots or complex roots, it can't cross the axis. That's my plan. So x is minus b plus or minus the square root of b squared minus 4 times 17 minus 68 all over 2. So that's 4 plus or minus. It's going to be a half of root minus 4. So that's going to be 4 plus or minus. That's going to be I. Complex roots, therefore, doesn't cross the axis. So it's positive. Number 2. Okay, it's like a riddle. If I had 3 to a square number, 3 to a number, sorry. I had 3 to a number, x plus 3. I'm going to square it. We're claiming the result is greater than the square of the original. All right, so we need to solve this inequality. X squared plus 6x plus 9 must be greater than x squared. That only works if... So the x squareds will cancel, and that will only work if 6x is greater than minus 9. So x must be greater than minus 9 over 6. So if x is bigger than minus 3 over 2, then it works. So it's false in general, because it says it's sometimes true. It's true for, so it's true if x is greater than minus 3 over 2, and it's false otherwise, e.g. when x is minus 2, x plus 3 squared is going to give me x plus 3, is 1, and x squared, of course, is 4. So then it would be false. All right, I think I've done enough for that one. So, question 3. Right, vectors. So we've got a position vector. We've got A is 4i minus 5j, which I can write as 4, minus 5. We've got B is in the position minus 5i minus 2j, which I can write as minus 5 minus 2. Find AB. Right, and that's part A. Wants me to find AB. So let's just draw a diagram. So A is going to be 4 across, minus 5 down. That's down here. So that's A. And then B is minus 5, minus 2. So that's like here to B. If I want to go from A to B, which is going to be this dotted line, that's minus a plus b. Right, so that's b minus a. So that is going to be minus 5i, not plus, minus 2j. And then minus a, so that's minus 4i. And then minus becomes a plus 5j. So putting all of that together, I get minus 9i plus 3j is AB. And that works. I'm going left a lot and up a little bit. Perfect. Now B wants me to know the length of this vector. So that's the square root of the 2 bits squared. So that's 81 plus 9 square rooted, which is root 90, which is 3 root 10. I think that's simple as it gets. All right, so that's me about some lines. So question 4, we've got L1 given by 4y minus 3x equals 10. So 4y is 3x plus 10. So y is 3/4 x plus 10 over 4. So the gradient's going to be important here because it's asking me about parallel perpendicular. And then if I look at L2, that's going to tell me now it's got to pass through the points 5, minus 1, and minus 1, 8. So let's think about the graph. So 5 across, minus 1 down, minus 1 up, 8 up. So that's going something like this. Okay, and we want to know that gradient. So the gradient, let's call it M2 for L2, is difference in the y values. So that's 9 divided by the difference in the x values, minus 1, minus 5, minus 6. So the gradient there is minus 3 over 2. Gradient up here is 3/4. So their product is not minus 1. So they are not, and they're not the same. So they're not parallel, not perpendicular. So the answer is neither. Okay, question 5. So, oh, I'm marking a student's work. I'm used to this. This is a fun A-level question. Definitely didn't have these when I did A-levels. All right, so try and solve this problem, identify some errors, write the question. Right, so I'm going to just solve it myself, and then we'll compare. I think that's the easiest way to do this. So, right, so we're looking at 2 log base 2 of x minus log base 2 of root x equals 3. Okay, so first thing I'm going to do is put that 2 inside, becomes x squared, 2 root x. Then I'm going to combine the logs using the subtraction rule, so that's then x squared over root x from there. And that has to equal 3, yeah, then that's log 2 x to the 3 over 2 is 3. And then, I think the way this works now is I'm trying to work out, I know that I'm saying here that 2 cubed must equal x to the 3 over 2. So that's 8. So 8 is x to the 3 over 2. So let's cube root both sides. So if I cube root both sides, I get 2 equals x to the half. So x is 4. All right, so I think x is 4. And the student's got 9, so there's a mistake. Right, what did they do different? Right, so the first mistake is the student has left the 2. They've pretended that there was a 2 inside that log. So the subtraction law, they couldn't use the subtraction law until they'd done the powers. So for mistake 1, let's write mistakes. They use the subtraction law before the powers. Okay, and then I think what's happened is at the end, they've said log 2x is 3. That doesn't mean that x is 3 squared. That means that 2 to the 3 should be x. So I think they've used the definition. So they've used the incorrect definition of log. And I stand by my answer, and I'm going to just double check it makes sense by plugging it in. So log to the base 2 of 4 is 2. 2 times 2 is 4. And then minus the log to the base 2 of 2 is 1. Perfect. equals 3, tick, and a smiley face, because we did it correct. Right, that's number 5. Okay, question 6. This looks like economics, which I did not do at A-level. Hopefully you can figure this out. Right, so question 6. What are we doing? We've got a graph, we've got a function. Okay, so profit, hundreds of thousands of pounds. Okay, so that's 100,000 minus 6.25 times x minus 9 squared. Okay. And then we've got this graph. Right, so we can see here very clearly that there's a peak profit, a maximum profit here, and then we're going to make a loss at certain values of x. Okay, good. And x is the selling price. Fabulous. Right, using the model explain why £15 is not a sensible selling price. Well, let's plug that in, see what we get, right? So if I have question A, 15 is a bad idea, so suppose x equals 15, then P is going to be 100, which is in thousands, remember, minus 6.25. X minus 9, that's 6 squared. So that's 100 minus, which equals 100 minus 6.25 times 36. Right, that's greater than 100. Don't need to know the number. So profit's negative, bad idea. Gonna lose money. Right, part B. According to the model, the least possible selling price for the toy, given they made a profit of more than 80. Right, well, let's see what happens if their profit was 80. So suppose P was 80. Then you've got 80 is 100 minus 6.25 times x minus 9 squared. Right, so now minus 100 from the 80 gives you minus 20. Minus 20 equals minus 6. Right, make both those pluses. 725 times x minus 9 squared. Okay, so x minus 9 squared is equal to 20 over 6.24. Calculator. Right, come on then, Casio. Don't know if I still know how to work this. 20 divided by 6.25 is 16 over 5. Even gave it me, don't you can see that? Gave it me as a fraction. Awesome. All right, so 16 over 5. Okay. So that means what? That means that x minus 9 is equal to plus or minus 4 over root 5. So that means that x is equal to 9 plus or minus 4 divided by root 5. So in order to get exactly 80 as the profit, x is either 9 plus what was 4 divided by root 5. I guess I better do that. 4 divided by the square root of 5. Oh, it's very helpfully given me a fraction, which I don't want. Oh, how do I change this? It's been a while since I did this. There's got to be a way to do this. I don't want a fraction. I want the number. Mode? No. Don't want that. No. Shift? No. Alpha? This is going to annoy me. I don't want to round. I want the exact answer. Please, calculator. Don't do the... Ugh. All right, I don't think this is going to help me. All right, we're out. Don't know how to do the calculator. Okay, so it's 9 plus or minus 4 root 5. So for one of those two values, the profit is 80. So that would give us 2 points up here then, wouldn't it? It would be like one would be here and one would be here to give us 80. So the least possible selling price is going to be 9. So the least possible, I believe, will be 9 minus 4 divided by root 5 pounds. All right. Calculator won't give me better than that. I'll have to deal with it. Okay. Wishes to maximize annual profit. Stated according to the maximum possible profit. Right, so now if I'm maximizing profit, I think what we need to do this time is find that turning point at the top. So we're going to have to differentiate and find this p-value and that x value. Okay, so where's my equation again? So we know that p equals 100 minus 6.25 times x minus 9 squared. So dp by dx, let's differentiate, set that to 0. So that's going to be minus 12.5 times x minus 9. So that's 0 at the max. So in other words, x is 9 at the maximum. So that's the best selling price to maximize profit. And then if x is 9, their profit will be £100,000 because the second bit's 0. So their profit will be £100,000. They sell the toy for £9. Perfect. Oh, right. Staying hydrated. So question 7. Okay, we've got a triangle ABC. Let's draw a triangle. Okay, A, B, C. What do we know? AB has side length 10. This has side length 5. This is theta. Okay, fabulous. I'm going to want to know the height. So let's call that H. Okay, and then the area, we're told that the area here is 15. That's a half base height. That's a half 5 H. So that tells me that H is 6. Okay, so that's helpful. So now we know, let's call that 6 up here. Okay, and then we know what now? We know sine. We know that sine of theta is opposite over, so that's 6 over 10, which is 3 over 5. And then you've got your 3, 4, 5 triangle. So that tells us what? This is 3, 4, and 5. Then cos of theta must be 4/5. So that's one value. I'm guessing, and then if we go from here, I've definitely done this the wrong way. If we go from here, maybe we can say cos squared is 1 minus sine squared. 1 minus 9 over 25. So cos squared is 16 over 25. So cos of theta is maybe plus or minus 4/5 would also work. All right, that's 2 answers. It does say 2 possible. I'm going with that. Okay. Right, and then the second part, find the exact length of BC. Oosh, okay. So what do we know then? So we know that cos of theta, and we know sine of theta. So we could figure out theta if we needed to. How am I going to find the length of BC? Kind of maybe cosine rule. So what do we know? So if this is A, this is C, and this is B. Oh, I've got to remember the cosine rule. The cosine, this is a formula. Maybe I should look at the booklet. But I didn't look at the booklet. Okay, cosine rule I think says that, I think it says that A squared is B squared plus C squared minus 2BC cos of theta. Cos of A, where A is opposite. Yeah, okay. I think that's right. We'll see. So I think A squared must be B squared, which is 25, plus 100 minus 2 lots of 5 is 10 minus 100 again, cos of theta, which is 4/5. So A squared, well, it could be plus or minus that, I guess. It's going to be minus, I think, looking at the diagram. But that could be plus or minus, I suppose. And then 25, so it's 125 plus or minus 80. So if it was 205, I think the triangle would be too big. So I'm going to say, I think A squared must be 45. So that tells me that A is the square root of 45, which is going to be 3 root 5. So I think A is 3 root 5 centimeters. I've just reread the question. Good practice. And I've noticed it says BC is the longest side. So 3 times root 5, that's going to be less than 10. So it's not that. So it's plus. My apologies. So that's going to be, always read the question, everybody. That's going to be plus the 80. So that's going to be 205 now. So A is the square root of 205. That's the answer, not the other one. Read the question. BC is the longest side. All right, now I'm happy with that. All right, question 8. Ooh, a lorry is driven between London and this is fun. London and Newcastle. A simple model, the cost of the journey, and the speed is, okay, so we've got C is given by 1500 divided by the steady constant speed V plus 2V over 11 plus 60. Right, find according to the model the value of V that minimizes. All right, so minimizing means differentiate, solve for 0. So dc by dv is minus 1500 over v squared plus 2 over 11. We want to solve that equal to 0. So that tells me that 1500 must equal 2v squared over 11. So 11 times 1500 must equal that. So v squared is, going to make me use a calculator again. 1500 times 10, 15,000, 16,500, I think. Yes, divided by 2. Okay, so that's 8,250. So V is the square root of 8,250. Okay, so square root of 8250 is 5 root 330. This calculator is useless. Equals 5 root 330 is the speed. I don't even know if that's, I think it's reasonable. All right, so that's our speed. The minimum cost, solutions based on time, graphical and numerical methods are not acceptable. Interesting. Okay, so then the minimum cost of the journey is then plugging that in. So the cost C is then equal to 1500 over 5 root 330 plus 2 times 5 root 330 over 11 plus 60. So that mess of a number, can I simplify it a bit? Probably. Let's say it was 300 over root 330 plus 10 elevenths root 330 plus 60. Oh, do I really have to do this? Probably also not. Fine. All right, prove by using the second derivative the cost is minimized. Okay, so for it to be a minimum, second derivative is positive. So we had that dc by dv was minus 1500 over v squared plus 2 over 11. So then the second derivative is going to be b to the minus 2, so that comes down, becomes a 3000 over v cubed, which is positive because v is velocity, so it's positive. So therefore minimum. Good. And then state one limitation of this model. So that was B. The limitation of the model, don't drive at constant speed. Obviously there's accelerating, there's decelerating, etc. So we don't drive at constant speed. Okay, question 9. So what is this asking me to do? Use the factor theorem to show that x plus 2 is a factor of this. Okay, so g of x is 4x cubed minus 12x squared minus 15x plus 50. And then we'll show that x plus 2 is a factor. So x plus 2 is a factor if g of minus 2 is 0. So let's calculate it. G of minus 2 is 4 lots of minus 8 minus 12 times 4 plus 30 plus 50. So that's minus 32 minus 48 plus 80, which is 0. Hooray! So that's a factor. Perfect. So that was part A. Part B says, hence show that g of x can be written in this particular form. Well, that just follows from the fundamental theorem of algebra, which I'm pretty sure is not what I'm meant to say, but I'm going to say it. So we know that. Okay, so therefore g of x is x plus 2 times some squared. Right, so let's figure it out. So I need to get 4x cubed, I need a 4x squared. And then I've got plus 8x squared, so I need to then minus a lot of x squareds. Because I've got plus 8 of them, so I need to then minus 20 of them. Yeah, and then I've now got minus 40x, so I better add 25 of them. That gives me the 50. Perfect. So that's going to be x plus 2, and that's going to be 2x plus 5. Minus 5. 2x minus 5. So what that's going to be will be the correct solution there, squared. And let's just double check. 4x minus 20 plus 5. Perfect. Okay, good. So that's finding A and B. A is, so what have I got to be proper? I can say that A is 2 and B is minus 5. Great. Part C. Figure shows a sketch of this curve. Use your answer part B and the sketch. Deduce the values of x for which that. Right, so I know that the roots when it crosses 0 are when x is minus 2, and then it touches at 2x equals 5, so when x is 5 over 2. So therefore from the sketch, g of x is negative, g of x is less than or equal to 0 for x less than or equal to minus 2. And then g of 2x is 0. Interesting. G of 2x equals 0 when at any of the roots. Okay. So I know that bit. Minus 2. And then g of 2x. So 2x stretches it. But the 0 roots will stay the same. So I think this is true when 2x is a root of g. So this is when 2x is a root of g. And then we know the roots. We know that one root is minus 2. So 2x equals minus 2. So that means that x is minus 4. Okay. Fine. And then we also need 2x to be the other root, which was 5 over 2. So 2x equals 5 over 2 tells me that x is 5 over 4. So I think at these points, I think we have g of 2x is 0. All right, question 10. Must be getting there soon, surely. How many questions can there be? Proving first principles, the root of x cubed is 3x squared. Right. Okay, so that's so f dashed of x is the limit as x goes to, not as x, the limit as h goes to 0 of, as h goes to 0 of f of x plus h minus f of x all over h. Right, so here we're using the derivative of x cubed, so that's the limit as h goes to 0 of x plus h cubed minus x cubed over h, which is the limit as h goes to 0 of x cubed plus 3x squared h plus 3h squared x. Plus h cubed minus x cubed, I think is what we're going to get there, yes, divided by h. Then the x cubes cancel, I can cancel the h's, so this is the limit. So this is the limit as h goes to 0 of 3x squared plus 3xh plus h squared. And then we can take that limit because there's nothing on the denominator, and that's just 3x squared. Smiley face. Awesome. Right, question 11. Part A, binomial expansion. There's probably a formula for this. I'm gonna Taylor expand, so I'm gonna write this as 2 minus x over 16 to the 9. Right, so I can factor out a 2, and there's 1 minus x over 32 to the 9. And then that's going to be 2 to the 9 times 1 minus 9x over 32 plus, you're then going to get an x squared. You're going to get a 9 times an 8 divided by 2. And then you've got 32 squared on the bottom, which is 2 to the 5, 2 to the 10, plus dot, dot, dot. Okay, so if 32, oh, do I really have to work out 2 to the 9? Calculator, 2 to the 9, forget I'm allowed these. Okay, 2 to the power 9 is 512, thank you, right. So I think this is 512 minus, what's 512 divided by 32? 16 minus 9 times 16 x plus, whoa, what have we got on the top and the bottom? I've got a 2 to the 12 from the 2 cubed and the 2 9, that's 2 to the 12. Then I've got a 9x squared over 2 to the 11. So the first three terms are 512, 9 lots of 16 is 144x, plus 18x squared, I hope. Okay, so part B. Part B is then asking me, given that the first, oh, we've got another function. Okay, so we've got another function, f of x, a plus b x times the thing we just played with. Right, so that's going to be helpful. Okay, a being a constant. The first two terms are those ones, find the value of a. Okay, so we know that this is a plus bx times 512 minus 144x plus dot, dot, dot. And they're told this has to equal, and we're told that this has to equal, the first two terms are 128. So we know that this has to be, has to equal 128 plus 36x, right, and then if we actually calculate it, so that's 512a, first term, minus 144ax plus 512bx plus order x squared. Right, so if we equate them, we know that 512a is 128. So that tells me that a is 128 over 512 is 1/4. Okay, so a is 1/4. And then for b, what have we got? So if a is 1/4, oh, then for b, we've got to equate the coefficient of x. So we need 36 has to be equal to 512 times b minus 1/4 of 144 minus 36. So b is 72 over 512 and a is 1/4. Sweet, I hope. Nasty numbers. I don't know if you expect these weird numbers in A-level exams. Right, question 12. Show the equation written. All right, like these things. So, for cos theta minus 1 equals 2 sine theta tan theta. Okay, so tan is sine theta over cos theta. So let's just start by writing that out. And show it written like that. Right, so I'm going to multiply it by cos, so I'm going to get 4 cos squared theta minus cos theta equals 2 sine squared. And then I'm going to sub and say, well, that's 2 lots of 1 minus cos squared theta. So I'm going to get 6 cos squared theta. minus cos theta minus 2 is 0. That's what I wanted. Hooray. Okay. And then part B, hence solve for x between 0 and 90. Okay, so hence solve for x between 0 and 90, the whole thing. Oh, not quite. So we're solving for cos 3x minus 1 equals 2 sine 3x tan. Right, so 3x is just theta. But I have a quadratic for cos, so I can solve this. This is just 6y squared minus y minus 2 is 0. So what do I know is going to be my answer? I can factorize this, or I can use the quadratic formula. So y is equal to 1 plus or minus the square root of b squared 1 minus 4ac plus 48. Okay, all divided by 12. So y is 1 plus or minus square root of 49 is 7 over 12. So y is equal to 8 over 12, or 1 minus 7 over 12 minus 6 over 12. So we know that cos of theta is equal to 8/12, that's 2/3, or minus 1/2. And we're looking for the range 0 to 90. So 0 to 90, cos between 0 and 90 is positive, so it has to be that. So we know that theta is arc cos of 2/3. So I know that 3x is equal to cos minus 1 of 2/3. I'll have to use my calculator again. Okay, so cos minus 1, I think I can do that. Cos minus 1 of 2 divided by 3. Okay, and then, so x is just that divided by 3. I think this is going to be in degrees. So it's going to be 16 answer divided by 3. It's going to be 16. How many decimal places? 1 decimal place. All right, 16.1 degrees, I believe is the answer. Right, question 13. Ooh, we have a graph again, it's like economics, values of paintings. All right, question 13. The log of a rare painting modeled by the equation V equals P times Q to the T. Okay, P and Q are constants in of years, right. Line L shows the linear relationship between T and log 10 of V. So this is log to the base 10 of V. Fabulous. This is time. Yep, great. And then you've got a line that's going to look like that. Fab. The equation of the line, and we know the equation. Fabulous. So we know that log 10 of V equals 0.05t. So that's the gradient of my straight line plus 4.8, which is the intercept. So this is 4.8. And then I know that the gradient m is equal to 0.05. Fantastic. Find to 4 significant figures the value of p and the value of q. Right. So what I have to do here is we need to exponentiate both sides to the power 10. So v is equal to 10, 0.05t plus 4.8. So that's equal to 10 to the 4.8 multiplied by 10 to the 0.05t. Right. And we want to write this as p is pq to the power t. So that's equal to 10 to the 4.8. So that's p, and then q is 10 to the 0.05t. So this is p, this is q. Put them in my calculator. 10 to the power, power button, 10 to the, where are you? There, 4.8. So p is 63. How many figures? 4 significant figures. 630, and it's 95. So that's 631, I think. 6309. You'd go up. Yeah, 63. That's p, and then q is 10 to the 0.05. 10 to the 0.05. It is q then is 1.1220. So 4 significant figures, delete that last 0. All right, so that's P and Q. Now, reverse to the model, interpret the value of the constant P and the value of the constant Q. So here, Q is representing the rate of increase, right? So Q is representing the increase in value over time. So I think for part B, Q is the rate of increase in value over time. So that's like how much it's going up as it progresses. And P is equal to its initial starting value, more or less. Yeah, P is the sort of initial value at the time of creation. Initial value. All right, find the value of the P times predicted by the model on the 1st of January 2010. Give me your answer nearest 100,000. Right, so we've got part C. We know P and Q, and we're asked about on the 1st of January 2010. So we know that P now is equal to 60,100. We've got that Q is 1.122. And so, what else do we know? So it's since the 1st of January 1980, right? And we're told that V is equal to P Q to the T. So if we want to know its value on 2010, that's 30 years. So T is equal to 30 years. So the value is simply 63,100 multiplied by 1.122 to the power 30. So plugging that in my calculator, 1.122 to the power of 30. Oh, syntax error. That's a new one. Let's try again. 1.122 to the power 30. Thank you. It was 31.6, and then multiplied that by 63,100 equals to how many significant figures? Nearest £100,000. So that's, I think this is £1,994,413. So nearest £100,000 means this is worth £2 million in 2010. Okay, question 14. This is never ending. Question 14. This is intense, by the way. I'm now beginning to feel a little bit of sympathy for you all. This is long. Question 14. The circle C has this equation, right? X squared plus y squared minus 6x plus 10y equals minus 6 plus 10y plus 9 even. Don't make a mistake writing the question out. Equals 0. Okay, find the coordinates of the center, the radius. Okay, brilliant. So you want to complete the square. So that's going to be, let's think about this, completing the square there. You've got x, this is part A, x minus 3 squared gives me the minus 6x, and then I need to, that will be plus 9, so I need to minus 9. Okay, covers those two terms. Plus y plus 5 squared, that gives me plus 25 minus the 25 plus 9 equals 0. So I get x minus 3 squared plus y plus 5 squared equals, okay, so minus 9 plus 9 equals 25. So the center is 3 minus 5, and the radius is the square root of 25, which is 5. Brilliant. Okay, so 14 part B. So we've figured out the center of, right, yeah, gotcha, okay. Thought we'd be doing something like this. So we've got, we know the center of the circle. That was 3 minus 5. And then it's going to have radius 5. So it's going to look something like that. It's going to touch the x-axis, but it's going to overlap there. And then we're going to have a line here, and we're interested in what's this gradient so that they perfectly touch, where this is y equals kx. Right, and we know that this is at 3 minus 5, and it has radius 5. Okay, so we know this far over point is at x equals minus 2. All right, so I think what we're going to do here then is plug in y being equal to kx into my equation. So I get x squared plus k squared x squared minus 6x plus 10y plus 10kx plus 9 equals 0. And then if they're going to intersect, this has to be equal to 0. This has to have solutions. This will have to have solutions. So let's quadratic formula. So I can get 1 plus k squared times x squared plus x times 10k minus 6 plus 9 is 0. So I can then say that x is equal to minus b, so 6 minus 10k, all divided by 1 plus 2 lots of 1 plus k squared, plus or minus the square root of 10k minus 6 squared minus 4 times 9 times 1 plus k squared. Right, and if this is going to have real roots, for it to exist, we have to have positive discriminant. I think. Let's try that anyway. It's definitely true, but I think that's the way to do this. So we can say now that we need positive discriminant. So we have to have, so we need 100k squared minus 120k plus 36 minus 36 minus 36k squared to be positive. So those two cancel. So we need 64k squared greater than 120k. So we need k bigger than 120 over 64, which is going to be 15 over 8. So k can be greater than 15 over 8 to get the intersection there. Could it be negative? And then if we had a negative gradient, it's always going to intersect, isn't it? Yes, yes. Or, okay, negative. Right, last question. Here we go. So we've got to figure out this area. Of course we do. Okay, and it's quite fiddly. So let's think about a careful diagram. So we have a curve coming down, going back up. We know this is coming in at x equals 2, so that's helpful. We know the other point is 4. It also corresponds to 6. Okay, then we have this straight line coming down. So we need to know this intercept, and that would give us a triangle, and then we can add to the integrated area. Right then. So let's do the integrated area first, because we know that. So let's say that can be the blue section, this bit here, blue, grey, same thing. So this area is just the integral from 2 to 4 of 32x to the minus 2 plus 3x minus 8 dx. So that is minus 32 over x plus 3 over 2x squared minus 8x between my two limits. So that's going to be minus 8 plus 3 lots of 16, 48 plus 24 minus 32 minus the second lot minus 16 plus 6 minus 16 again. Okay, so that should give me minus 40 plus 24 minus 16 minus 26. So that gives me 10. So I think this area is equal to 10. So hopefully the triangle will be 36, and then we've got the answer. Because we were asked to show that it was 46. So for this area, we're going to need to calculate the equation of the line. But what do we know? We know that this is normal, so we need to know the tangent. So let's calculate the tangent gradient, so differentiate our function. So dy by dx is, what have I got there? I've got to the minus 2, so minus 64 over x cubed plus 3 Right, and then I need to know the value of this at x equals 4. So the gradient at x equals 4 is given by minus 64 over 64 plus 3. So that's equal to 2 for the tangent. So the normal gradient is going to be minus 1/2. So the equation of this line is y equals minus 1/2 x plus c. And then we know it goes to the point 4, 6. So we know that 6 must equal minus 1/2 of 4 minus 2 plus c. So c is 8. So then here we know x is 0, no, y is 0. So that tells me that minus 1/2 x plus 8 is 0. So x is 16. So I've got a triangle 16 and height 6. So it's going to be 16, is the value here. So the value along the bottom is from 4. So that's 12, of course, isn't it? Because it's from 12 to 16. So that is now 12. So half base times height is 36. Yes, 6 times 6. So the area of the orange is 36. And then the total is 36 plus 10. 46, what we had to get. Yes. Whew. Okay. Phew, I'm relieved more than anything, I think, that I did get those questions correct. At least I think. I certainly used some different methods from what I'm seeing in the mark scheme, but I'm getting the same answers. So you have to be awarded the marks for getting the correct answers. So I think, fingers crossed, touch wood, I think I would have indeed got 4 marks on that A-level exam. But that was quite tough. That was quite tough, I won't lie. Especially trying to do it fast. It feels like there's a lot more pressure when you're trying to do it as quickly as possible. So that just leaves me to say thank you everybody for watching. I hope you've enjoyed the new style of video that I'm trying out. Please do remember to subscribe if you've enjoyed this video and check out all the other content on my channel, and I'll see you all very soon.